Now let's go ahead and learn to make our first function. Basic Solidity functions section. Functions or methods are a subsection of code that, when called, will execute a very specific small piece of our entire code base. If you're familiar with JavaScript or Python or any other programming language, functions in Solidity are exactly the same. Functions are identified by the keyword function. Let's create a function and name it store. And we're going to have this function be responsible for actually updating our favorite number. We're going to store a new favorite number. So you first write the function keyword, the name of the function, and then you add these two parentheses. Whatever is in between these two parentheses represents what we're going to pass or send to our function, or the parameters that we're going to send to our function. For example, we need to tell our store function what value it should use to update favorite number. So we're going to tell our store function it should take a uint256, and this variable that we're going to pass to it, we're going to call underscore favorite number. It's important that we give it a different name than favorite number up here, and we'll talk about that in a little bit. Then we're going to say this is going to be a public function, and we'll explain that soon too. We want to put these little curly brackets in here as well. And we're just going to say favorite number equals underscore favorite number. And without going too deep into what this is doing, we're saying, I'm not going to explain public yet, but we will in a minute. But what we're saying is whenever you call this store function, you're going to set our favorite number variable to whatever variable that we passed. I'll explain why we do this underscore here as well in a little bit. And with just this, we can actually start to simulate what this smart contract will do and if our store function will actually work correctly. So what we can do with just this code right here is come over back to the compile tab and hit compile, make sure that we get this green check mark and that everything looks good. And then we can go down to this deploy and run transactions tab. Our deploy and run transactions tab has a ton of different parameters in here on how to actually deploy and run with our transactions. We're going to deploy this contract to a simulated virtual environment. So we're going to deploy it basically to a fake environment. We're not going to be deploying it to a testnet. We're going to deploy it basically in kind of an imaginary world. In order for us to do this, first, make sure we're on this Remix VM. And for us, we're going to just use the default, which is the merge. Doesn't really matter which one you're on, just so long as it's the Remix VM. This Remix VM is a fake local blockchain where we don't have to wait for transactions to complete, and we don't have to deal with any of the oddities on deploying our code to a real testnet or a real mainnet. And don't worry about the rest of these for now. We also get an account here. When we run on our fake Remix VM, we get automatically given an account with a different amount of Ethereum for each account. You can think of each one of these accounts similar to our MetaMask accounts in MetaMask, except for these are fake imaginary accounts that Remix just gives to us. For our transactions, including deploying contracts, we're given a gas limit, values that we can send, and we'd also choose our contract depending on which one we've compiled. Since we only have one contract in here, we only have one to choose from. So on the left-hand side, to deploy our contract to this fake Remix VM environment, we're going to go ahead and click the deploy button. If we scroll all the way down to the bottom now, under this deployed contracts, we can see we actually deployed a contract here, simple storage. We can see the balance is 0, and we see this big orange button that says store, and then uint256 underscore favorite number. On our local blockchain, this at blah, blah, blah here, this is going to be the address of our contract. Similar to our wallets, how they have different addresses, every single contract has a unique address as well. And if we hit this little copy button and we close this and we put it as a comment here and we paste it, we can see this looks exactly similar to an address such as what's in our MetaMask. And then let's go ahead and open the deploy back up and we see that deployed contract is still there. Additionally, if you hit this little show terminal button and you pull this up, we can actually see we have this little comment here, creation of simple storage pending, and we have this green check mark here. This is notating that we actually sent a transaction to deploy this contract. Similar to sending ETH back and forth, in order for us to deploy a contract, we actually have to send a transaction. Since we're doing this on the Remix M, this is a simulated transaction, a pretend transaction inside of our Remix environment. You can even hit the little drop down and see even more information about this transaction. You'll see a lot of familiar keywords like status, transaction hash, from, to, gas, etc. Deploying a contract uses the exact same process as sending a transaction for just ETH. The main difference is we populate this data or input field with a ton of that bytecode. And if you copy this input field or this data field and go ahead and make a comment in here, you'll see it's a massive line. And this massive line notates all the data associated with this smart contract, all the machine readable code. Remember, anytime we do anything that modifies any value on the blockchain, we actually do that by sending a transaction. Deploying a contract is modifying the blockchain, so we do it in a transaction, which means, yes, we spend gas. Now, this big orange button over here actually resembles our function store in our smart contract. And if we add some numbers in here and we call it, again, if we pull the terminal up, we can see transact to simple storage pending, and we see we sent a transaction which called this store. If we do this again with a different number, we call it, we can see our terminal say, oh, you sent another transaction to update the state of the blockchain. And if we scroll all the way up to our account, you'll see that we have a little less Ether in our account because we had to spend the gas associated with, well, A, deploying this contract, and then B, calling these functions. And then, for example, if I add 5 in here and hit store, we'll send a transaction to store 5 on the blockchain. Now you might be thinking, okay, Patrick, that's pretty cool, but what is the value of favorite number? You're telling me that this function store is updating favorite number, but I can't really see it. How do I know that favorite number has actually been updated to 5? Well, the reason we can't see it is that the visibility of our favorite number is actually defaulted to internal. So us not having anything here or right internal are actually meaning the same thing. And we'll talk about visibility and default visibilities in a minute. But in order for us to actually see the value of our favorite number, we'll go ahead and add the public keyword to this. This changes the visibility of favorite number to public. And like I said, we'll talk about visibility in a minute. But let's go ahead and compile this. Let's go ahead and delete this contract by hitting this X here. And let's redeploy this contract with this new public keyword. So let's go ahead and hit deploy. And now if we scroll down and we open up our simple storage, we actually now see a blue button labeled favorite number. And if we click it now, we can see it returns 0, which makes sense because we know that uint256 is default to 0. Now, if I go ahead and add 5 into here and hit the store button, if I pull up the terminal, we'll see that we went ahead and executed that store function call, that transaction that's going to take input this 5 as favorite number and set it to our favorite number. Now, if I hit favorite number, you can see it does indeed return 5, showing that we actually updated our favorite number with this function call. And remember though, I'm going to go ahead and do this again. And remember, when I hit X here, this is just removing it from this window here. If you actually deploy a smart contract to the blockchain, hitting X from this window doesn't do anything because once you deploy your contract, it's immutable, it's out there, and you can't just delete it by clicking X and remix. Functions and variables can have one of 4 different visibility specifiers in Solidity: public, private, external, and internal. If you don't give one of these keywords to your variables, it'll get defaulted to internal. Public functions mean that they're visible externally and internally. And you'll see here it says it creates a getter function for storage/state variables. This means that other people can call this function or call this variable. When we didn't have a visibility for favorite number, it defaulted to internal, which is why we didn't see this blue number pop up, because internal. It means that other contracts and people aren't allowed to call on this favorite number. We have a little bit more here. It says it actually creates a getter function for storage/state variables. When we add this public keyword here, it's actually equivalent to us making a getter for this favorite number variable, a getter function. And I'll show you exactly what that function will look like in a little bit. Now, keep in mind though, everything on chain is technically public. So setting a function or variable to private isn't a good way to hide what the value actually is there. And we'll talk a little bit more about storage and visibility and that much later. Just remember, everything on these EVM chains is actually public data. This public variable just means any other contract can call this favorite number and see the value what's in favorite number. And private means only the current contract can. External functions mean they're only visible externally. And this is only for functions, not for variables. And it means another function inside this contract couldn't call an external function. And internal means only the current contract and its child contracts can call the function. We'll talk about child contracts and inheritance in a later section. So let's just keep it public for now. The reason that we have this underscore here in this parameter is because we need to tell users that this variable in here is different than favorite number. And there's a couple different conventions on naming local variables versus these what's known as state variables or variables outside of functions. And we'll go over those later in the course. Now, here's something that's really interesting as well. Remember how I told you earlier that sending Ether is a relatively simple transaction, right? Well, let's see what happens when we call this store function and we update favorite number to 5. Let's actually call it one more time. And we hit the little drop down here. Let's go to gas, and we'll see gas actually cost 27,000 gas, which is a lot more than the 21,000 gas it costs to just send Ether between accounts. Remember, every time you update the state of the blockchain, it's going to cost gas. Now, what do you think will happen if we do more inside of this store function? For example, we say favorite number equals itself plus 1. Let's go ahead and compile this. Let's delete our old simple storage. Let's deploy this new one. Remember, the last one cost 27 gas. Let's pull up the terminal. And Remix actually gives us a little tooltip, and it's saying an infinite gas, which we know is actually wrong. But let's go ahead and add 1, 2, 3 in here, and we'll hit store. We'll see this transaction. We'll scroll down. We'll see gas is actually a lot more. It's way more gas. It's 50,000 gas with just adding this line here. Now, technically, I'm not telling the full story here because there are some other gas costs associated with the first time you run a function, but it's still more, right? And that's what's important here. So let's go ahead and delete that line and go back to our old function here. Now let's talk about something called scope for a second. So if I create a variable in here called uint256 test var equals 5, and I create a new function called something, we'll make it public. Could I access the test var and then maybe change it to 6 or 7? What about the favorite number var? What about the favorite number variable? Could I access that to 7? Well, let's go ahead and see what happens if we try to compile this. If we try to compile, we actually go ahead and get an error in our compilation, undeclared identifier. Whenever you create a variable, it can only be viewed in the scope of where it is. If that's confusing, just look for the curly brackets. The reason that our something function can read the test var is because this test var isn't inside of the curly brackets of something. The reason it can't read the test var is because test var was created way up here inside of these curly brackets outside of something. But favorite number wasn't created inside of these curly brackets, so how come it knows what favorite number is? Well, something is inside of these curly brackets, and favorite number was created inside of all of these curly brackets. If favorite number was created inside of here, it wouldn't be able to access favorite number because, again, favorite number is inside of this scope and not this scope. If you create a variable like test var inside of store, you can only access this test var inside of this store function and not anywhere else. The easy way to know what the scope of a variable is just look for the curly brackets. So let's go ahead and delete this something variable, and let's delete this test var, and let's recompile. Now, like we were saying earlier, when we add this public keyword to favorite number, it's the exact same as if we created a getter function to return this favorite number. So let's actually write a function similar to what this public keyword is creating. So we're going to say function retrieve. We'll make this a public view function, and we'll talk about that in just a second. And we'll say it returns a uint256, and we'll add the curly braces here. And we'll say return favorite number. And oftentimes when these auto suggestions come up like this, you can just hit enter and they will automatically do it. So if we do favorite and then I just hit enter, boom, automatically like that. Now I'm going to hit Command S, which is equivalent to me going to the compile tab and hitting compile. Now, if I go to the deploy tab and let's deploy this contract now, when we scroll down, we now see we still have that store function. We have our favorite number function, and we have a new blue button called retrieve. Right now, they both start off as 0. And then obviously if we update this to 5 by calling store, yep, I called store, these now both return 5 since favorite number is the actual variable and retrieve is just returning whatever favorite number is. Now, as you can see here, these two functions are blue, but this one is orange. What's the difference? Why are the colors different? Well, the key is actually with this view keyword here. Solidity has a special keyword which notates functions that don't actually have to run or you don't actually have to send a transaction for you to call them. And those two keywords are going to be view and pure. A function marked view means we're just going to read state from the blockchain. For example, in our retrieve function, we're just going to read what the favorite number variable is. Our store function isn't reading, it's updating something. And it's changing the state of the blockchain. So we have to send a transaction. Since our retrieve function doesn't have anything inside here that updates anything, it just returns favorite number, we don't need to send a transaction. So if you add this view function in here, it disallows any modification of state. For example, I couldn't add favorite number equals favorite number plus 1. If we go ahead and try to compile this, we'll get an error. Function cannot be declared as view because this expression potentially modifies state. So we'd have to remove this line, or we'd have to remove the view keyword. So view functions disallow updating state, pure functions disallow updating state, and they disallow even reading from state or storage. This favorite number here is what's known as a storage variable because it's stored in a place called storage. We'll talk about that in a later section. But if this was labeled pure, we'd see we get a little red underscore here because favorite number is reading from state. Instead of returning favorite number, we would return something like 7. So this would be an example of a pure function. This would be an example of a view function because we're reading from state. Again, we'll explain the difference a little bit later. And like I was saying before, if we call a view or a pure function, we actually don't need to spend gas since we're not modifying the state. That's why these buttons over here are blue. They're representing view or pure functions, functions that we can call without having to send a transaction. For example, if I pull up the terminal here, and I pull this up, and I call retrieve, we do get another function, but it's just a call, and it looks different than if I hit the store, which has this little check mark. They're different because the store is obviously sending a transaction, and the retrieve is actually just making a call and not sending a transaction. However, something weird is going on here. If I hit retrieve and I go into the details of this call, I can see, oh, what's this? Why is there an execution cost? It says cost only applies when called by a contract. What's going on there? The reason for that is because if another function that does update state, that does require a transaction, calls retrieve, that transaction does need to pay the gas of reading and calling this retrieve function. So calling a view or pure function actually does cost gas only when a gas cost transaction is calling it. So we can go ahead and call these as much as we want. It costs nothing. But if another function that does cost gas calls it, it's going to cost something. For example, if our function store here then went ahead and called retrieve like this, since store costs gas, you're telling this function, hey, also call this retrieve function, which is more work for it to do. And since it's more work, it's going to cost more gas. So for example, if we delete this contract over here, let's go ahead and compile this. Let's go ahead and deploy this with this retrieve in here. So let's go ahead and look at these. These are now 0. We'll store 5 in here. We'll select the dropdown. We can see how much gas we actually sent, 50,000 gas. Let's go ahead and drop this now, close this out. Let's remove the retrieve line. Let's compile, we'll hit deploy, simple storage. These are both 0. We'll add 5, hit store, pull up the terminal, hit the dropdown, look at gas. It's still 50,000, but it's actually a little bit less than before. Although I'm pointing at gas, we really should be looking at transaction cost because gas is really just actually how much we're sending, whereas transaction cost is how much gas the transaction actually cost. But in any case, it was a little bit less without the retrieve function. Now I've kind of been glossing over this a little bit, but this returns keyword specifies what this function is going to give us when we call it. So when we have this returns keyword in our retrieve function here, we're saying whenever we call this retrieve function, we want to get returned or we want to be given this favorite number of type uint256. We want to return a uint256 from this function.